Hello, Algebra 2 students. We're starting section 3.3, Optimizing with Linear Programming. And in this video, we can find the maximum and minimum values of a function over a region. So this is a pretty intense lesson. You might have to pause it a few times, rewind, might have to take a break, a water break every now and then, but yeah, there's a lot of information here. So, some vocabulary. Let me highlight what you need to know, what words you need to know, and then you can pause the video and write this down. So linear programming, what the heck is it? Linear programming is a method of finding maximum or minimum values of a function over a given system of inequalities, with each inequality representing a constraint. And I'll show you what that looks like. You're going to be given a function and some inequalities, so you get the best of both worlds. Now, after the system is graphed and the vertices of the solution set called the feasible region, so the vertices are called the feasible region, are substituted into the function, you can determine the maximum and min value. So we're going to be doing some graphing. We're going to find those vertices and then we're going to plug them into this function. So lots of fun here. So what's it going to look like here? When we graph stuff, it's going to look like this. We're going to have some bounded regions where we have vertices or this vertex here. The feasible region is the stuff on the inside. Your constraints are your lines that you're drawing. And here, this would be an unbounded region. So notice this shading goes on. And the feasible region is not enclosed or not bounded. So let's try this out. So we're going to graph the inequalities, name the coordinates of the vertices of the feasible region, then find the max and min values. So lots to do, lots and lots to do. So let's go ahead and graph the inequalities first. So the first one, the first inequality is to graph y is in between 3 and 6. So remember, when y equals a value, it's a horizontal line. So at 6, 1, 2, 3, 4, 5, 6, we're going to have a horizontal line. And it's going to be solid. All of them are going to be solid, aren't they? And then 3, 1, 2, 3. Like so. And I'm going to pause the video here and make this. Alright, so the next one is going to be 3x plus 12. 12 is up here, so we go down 1, 2, 3, to the left 1, because it's a positive slope. 1, 2, 3, to the left 1. So let me finish this. 1, 2, 3, here. And again, this is going to be a solid line. And then we have one more, negative 2x plus 6. So we're going to go ahead and graph that guy right there. So here we're going to start at 6. We're going to go down 2 to the right 1, down 2 to the right 1. One more. Alright, sorry about that. I had some announcements there. So now what we're going to do is find the vertices, and this is what we're going to plug them into. We're going to plug them in right here. So let's find the vertices of our bounded region. So we have 0, 6. Okay, hopefully that's the last announcement. We'll see. It's at the end of the day here. Alright, and then we have negative 3, 3. So these 4 vertices, we're going to go ahead and plug them in to our function and see what the max value is and what the min value is. Alrighty, so I'm going to do that on the next slide, so make sure you have this written down. So I made a little table like this to kind of help us out. So we have, and I'll pause the video here, you guys can pause out and go ahead and write this out. I won't waste your time having you guys watch me do this. So go ahead and pause the video and fill this table out. Alright, so here are the values. And we look at the max value. The max value is 0, and that is at 1.5 comma 3, and the min value is at negative 20 at negative 2 comma 6. So that would be our answer. And this is how you do a bounded region. Alright, let's do another example with an unbounded region. Alrighty. So go ahead and pause the video, and I want you to graph this, and we'll see what you get. See if you get up with the same thing that I get. Alright? Alright, so this is what I got for my graph. And I just realized on that last example, guys, I did not do the shading. So make sure you go back to that example and put your shades in here. Alright. Okay, so this is an unbounded region. So let's see what we got here. When we plug in our vertices, and our vertices are negative 4 comma 0 here, and 0 comma negative 6. So when we plug those in, this is what we should get. Okay, a negative 36 and a positive 36. So when we do that, we have our max. Okay, our max is going to be 0, negative 6. This will be our max. And so minimum, now, why can I say there's no minimum? We could say this would be our minimum, but there's still something that we need to look at. Let's choose a value inside this shaded region. Okay, because it goes on and on up here. So like 0 comma 8, if I were to pick that, 0 comma 8 in the shaded region, what would I end up getting if I plug that in? A negative 48. So there is something less than this number. So that's why this is not our minimum. So we actually don't have a minimum, because this vertex here is not the smallest number we get when we plug in values in our shaded region. Okie doke. Alright, so that's all I have for you. I know that was a lot. You might have to watch it again. In class, you'll do a real world example, example 3 on page 156, and that's with optimization of linear programming. So how does this work in real life? Okie doke. Alright, we'll see you guys later.